Hey everyone, ready for another deep dive? Today we're taking on a topic that's really changing the game in AI. RG systems.
RG stands for Retrieval-Augmented Generation.
Okay, Retrieval-Augmented Generation.
And it's all about giving AI the ability to tap into a whole universe of information.
So instead of just working with the data it's already been trained on,
Exactly.
you can actually access and process information from external sources like the internet or massive databases.
It's like giving the AI a library card to the biggest library imaginable.
I like that analogy.
Yeah.
So how does this all actually work? What are the key components of a RAG system?
Well, picture it this way. Imagine the Starship Enterprise.
I knew you were going to bring in Star Trek.
It's the perfect metaphor. The Enterprise represents our AI system.
Okay, I can see that.
Just like the Enterprise needs information to carry out its missions.
Exploring strange new worlds, seeking out new life and new civilizations.
You got it. AI needs information to complete its tasks.
Right, but the Enterprise has that amazing library computer.
Yes. The library computer. That's where the retriever comes in.
The retriever.
It's basically the Enterprise's library computer, but on steroids.
On steroids, huh? So it's super powerful.
You bet. It can pull relevant information from external sources.
So it's like having a super-powered research assistant at the AI's beck and call.
Exactly.
Okay, but how does the retriever actually know what information to retrieve? How does it find the right stuff in that massive sea of data?
Great question. There are actually two main types of retrievers.
Two types. Okay, tell me more.
The first type is called a term-based retriever. It's pretty straightforward.
Straightforward how?
It works a lot like a simple keyword search.
Oh, I see. So if I type in Romulan cloaking device,
it will scan the data for those exact words.
Got it. So that's term-based.
Right. But then there's a second type, the embedding-based retriever.
Embedding-based?
And this one's a bit more sophisticated.
How so?
It doesn't just look for exact word matches. Instead, it converts information into a sort of numerical fingerprint called an embedding.
An embedding, okay.
And that fingerprint captures the meaning and relationships between words and concepts.
Interesting.
So it's not just about finding literal matches. It's about understanding the deeper meaning of the query and finding information that's semantically related.
Ah, so it's like Spock analyzing a sensor scan.
Exactly. It's using logic and reasoning to find the most relevant information, even if the wording is different.
I'm starting to see why this embedding-based retrieval is so powerful.
It allows the AI to be much more flexible and adaptable in its search.
Okay, so we've got our AI, our Starship Enterprise, and the retriever, our super-powered library computer.
Sifting through mountains of data.
Right. But what happens to all this information once the retriever finds it?
Think of it as compiling the captain's log.
Okay, the captain's log.
All that retrieved information provides crucial context for the AI.
Context. Why is that so important?
Because without context, the AI is basically flying blind.
Like the Enterprise trying to navigate a nebula without a star chart.
Exactly. The AI needs context to understand your request, to make sense of the information it's retrieved, and to formulate a helpful response.
Right, because just having a bunch of data isn't enough.
It's like having a library full of books but no idea which ones to read.
You need that context, that understanding of what you're looking for and why.
Precisely.
Okay, so we've got the retriever gathering information.
Providing context, like the captain's log.
Right. What's next? What happens to all this context? What's the next step in this AI voyage?
That's where the generator comes in.
The generator.
Yeah.
Another Star Trek analogy coming.
Of course. The generator is like Captain Kirk.
Captain Kirk. I should have guessed.
It's the part of the RJ system that takes all this retrieved information, that context we talked about, and uses it to generate a response, make a decision, or even take an action.
So if the retriever is like Spock gathering data, and the context is like the captain's log,
then the generator is Captain Kirk, making the decisions based on that information.
I love it. So the generator is what actually produces the output we see.
Whether it's answering your question, writing a piece of text, or even controlling a robot arm.
Wow. Okay. So we've got our Starship, the AI, its library computer, the retriever.
And Captain Kirk, the generator.
Working together to understand and respond to our requests.
Exactly. And just like on the Enterprise, there are safety protocols in place to make sure everything runs smoothly.
Safety protocols. So you're saying there's a risk that this whole thing could go haywire, that the AI might go rogue.
Well, not exactly rogue, but there are definitely risks involved when AI systems interact with information.
Especially when they have the power to act on it.
Exactly, and that's where the concept of guardrails comes in.
Guardrails. Like the safety rails on the bridge of the enterprise.
Exactly. We need to make sure that the AI uses information responsibly and ethically.
That sounds pretty important. But before we dive into the world of guardrails,
Which we'll definitely do in the next part.
there was this example I read about something about a printer.
Ah, yes, the printer question.
I think it was something like, will Acme's fancy printer A300 print 100 pages per second?
That's the one. It's a great example of why context is so crucial for RAG systems.
How so?
Well, to answer that question accurately, the AI needs to retrieve the printer's specifications.
It's like the enterprise needing to scan a planet's atmosphere before beaming down.
Exactly. Without the right information, the AI could give a completely wrong answer.
Or even a dangerous one.
Precisely.
Okay, I'm starting to see how this all fits together.
Retrievers finding information, generators creating responses, and guardrails keeping everything safe and sound.
It's like a well-coordinated starship crew.
Working together to explore the vast universe of data.
It makes sense of it all. Well, I'm definitely intrigued to learn more about these guardrails and how they work.
We'll delve into all of that in the next part of our deep dive.
Stay tuned, everyone. This journey is just getting started.
Welcome back, everyone, for part 2 of our deep dive on ARG systems.
I'm ready to explore the world of guardrails.
Guardrails are a critical part of any RA system.
Yeah, last time you compared them to the safety protocols on the enterprise.
Right, because we want to make sure the AI is using information responsibly.
So we don't have any accidental photon torpedoes going off.
Well, maybe not photon torpedoes.
What?
But there are real risks when AI starts interacting with information, especially if it's taking action.
Okay, like what kind of risks?
Well, one big one is the potential for the AI to leak sensitive information.
Oh, right. We don't want any Starfleet secrets getting out.
Exactly. Just like on the Enterprise, we need to protect confidential data.
So how do we do that? How do we prevent these data leaks?
That's where input guardrails come in.
Input guardrails.
They're like the security checkpoints at Starfleet headquarters.
Making sure only authorized personnel can access classified information.
Precisely. And they can use all sorts of techniques to prevent data leaks.
Like what?
Well, for example, they can automatically detect sensitive data.
Like credit card numbers or medical records?
Right, and then they can either block the entire query or mask the sensitive parts before the AI even sees it.
So the AI is never even exposed to the sensitive information in the first place.
Exactly. It's all about protecting data privacy and security.
That makes sense.
But input guardrails are only part of the picture.
There's more.
We also have to worry about something called model jailbreaking.
Model jailbreaking. Sounds intense.
It's when people try to trick the AI into doing things it shouldn't.
Oh, like those hackers who are always trying to break into the enterprise's computer.
Exactly. They try to find loopholes in the AI's programming.
To make it do something bad.
Right, something inappropriate or harmful.
So like what if a customer service chatbot suddenly started spewing out conspiracy theories?
That's exactly the kind of scenario we want to avoid.
So how do we stop these jailbreakers?
Well, we need strong defenses.
Like the enterprise's shields.
Precisely. We can restrict access to certain commands, filter out inappropriate language.
And even use anomaly detection to spot those tricky prompts.
Right, it's like having a security officer on board constantly monitoring for threats.
Okay, so we've got input guardrails protecting sensitive data.
And defenses against model jailbreaking?
What about the output? How do we make sure the AI isn't, going off the rails with its responses?
That's where output guardrails come into play.
Output guardrails.
They're like the enterprise's internal sensors.
Making sure everything is running smoothly.
Exactly. They're designed to check the quality and safety of the AI's responses.
So they're making sure the AI isn't spouting nonsense or spreading misinformation.
Or making claims that could damage the organization's reputation.
Right. We don't want to start any intergalactic incidents because of a faulty AI.
Absolutely. So these output guardrails, they can catch things like factual errors, offensive language.
Even just empty responses like the AI just goes blank.
Right. And they can also ensure that the AI's responses align with the organization's values.
So it's like having a communications officer on board, reviewing every message before it's sent out.
That's a great analogy.
Okay, all these guardrails are starting to make me feel a lot better about AI safety.
They're essential for building trustworthy AI systems.
But with all these checks and balances, doesn't it slow the AI down?
That's a valid concern.
Like, isn't it a trade-off between safety and speed?
It can be, but with careful design and optimization,
We can minimize the impact.
it's like streamlining security procedures on a starship.
You want to ensure safety without bogging down critical operations.
Exactly. It's all about finding the right balance.
Okay, so we've got retrievers generators, and guardrails.
What else do we need to make this RGA system work?
I don't know. Is there anything else?
Well, as our AI systems get more complex,
More complex.
we need ways to manage that complexity.
Like what?
That's where model routers and gateways come in.
Model routers and gateways. Are we building a whole fleet of AI now?
Haha. Well, in a way, yes.
So what do these routers and gateways do?
Well, think of the router as Starfleet Command.
Directing traffic.
Exactly. It analyzes the incoming query and decides which AI model is best suited for the job.
Oh, so like a complex scientific query might go to a specialized research AI.
While a simple question about the weather could be handled by a more general model.
And the gateway?
The gateway is like a starbase
Providing a secure point of access.
to all these different AI
It's
models,
all about coordination.
making sure the right AI is handling the right task.
It's like Starfleet coordinates its ships.
Precisely.
Okay, this is all starting to feel very Starfleet Academy to me.
Haha. Well, our GE systems are all about efficiency and organization.
Speaking of efficiency, what about caching?
Caching. That's like having a subspace relay station.
A subspace relay station.
It's all about storing information for quick and efficient retrieval.
So if the Enterprise keeps visiting the same star system,
It doesn't have to recalculate the route every time.
it can just use the cached information.
Exactly. And there are different types of caching.
Like what?
Well, there's prompt caching, which stores parts of prompts to avoid redundant processing.
So it's like having a pre-flight checklist already filled out,
Right. And then there's exact caching.
which stores the complete results of previous queries.
So if the same question comes up again,
The system can instantly grab the answer from the cache,
it's all about speed and efficiency.
like having a library of ready-made answers.
Exactly. But what about questions that are similar but not exactly the same?
Ah, good point. How do you handle those?
That's where semantic caching comes in.
Semantic caching.
It's even more sophisticated. It stores results for similar queries even if the wording is slightly different.
So it's not just about matching words, it's about understanding the underlying meaning.
Exactly. It's like the Enterprise's computer trying to understand different alien languages.
Wow, that's impressive.
But semantic caching is also more complex.
Right, I can imagine.
It relies on being able to accurately determine the similarity between queries.
Well, I have to say, I'm really impressed with how all these pieces of a RAG system fit together,
It's like a well-oiled machine,
or a well-coordinated starship crew.
working together to access and utilize information.
But I have a feeling we're just scratching the surface here.
Oh, absolutely.
What else is out there on the horizon of RAG systems? What are the truly mind-blowing possibilities?
Well, we're moving beyond just accessing information.
To actually taking action based on that information.
We're talking about right action.
Right actions.
Yeah.
Now that sounds intriguing. It's like the AI is not just reading the captain's log anymore. It's actually using that information to steer the ship.
That's a great analogy, and that's precisely what we'll be exploring in the final part of our deep dive.
Okay, so we're back, ready to explore those right actions you were talking about.
Right actions take our RAG systems to a whole new level.
Because now the AI is not just processing information.
It's actually using it to make things happen in the real world.
Okay, I definitely need an example here.
Sure, imagine you ask a RAG system to plan a trip to Paris for you.
Ooh, Paris. Now we're talking.
First, the system might generate a list of potential activities, visiting the Eiffel Tower, exploring the Louvre.
Indulging in some delicious French pastries, of course.
Of course. But here's where the right actions come in.
Okay, I'm listening.
Each of those activities, they can trigger further actions.
So, what would happen with visiting the Eiffel Tower?
Well, the AI could then check the opening hours, purchase tickets online.
Maybe even find a nice restaurant nearby for dinner afterwards.
Exactly. It's like having a personal travel agent powered by AI.
That's incredible. And you're saying this can be applied to all sorts of things, not just travel.
Absolutely. Think about customer service inquiries, automating business processes, even controlling smart home devices.
So the AI is gathering information, understanding the context, and then taking action based on that understanding.
Precisely. It's a seamless flow from information to action.
Okay, but I have to admit, the idea of AI actually doing things in the real world makes me a little nervous.
I understand that concern.
What if something goes wrong? What if the AI makes a mistake?
That's why we need to be very careful with right actions.
So we're not just giving the AI free rein to do whatever it wants.
Exactly. We need to establish clear guidelines, protocols.
Like Starfleet's regulations on the use of technology.
Precisely. And we need to constantly monitor the AI's actions.
Make sure it's staying within the boundaries.
And have mechanisms in place to intervene if necessary.
So it's like having a safety officer on board, making sure everything is running smoothly.
Exactly. Safety is paramount when it comes to right actions.
You mentioned something called observability earlier. How does that fit into all of this?
Yes, observability. Think of it as having sensors all over the enterprise.
Monitoring every system?
Precisely. We need to have deep insights into how the AI system is performing.
So we're not just looking at the final outcome.
We're analyzing every decision, every action, every bit of data.
So we can catch any potential problems early on.
Exactly. We need to track things like accuracy, latency, cost.
And log everything that happens.
From user queries to system responses.
So we can trace the flow of information through the entire system.
It's all about understanding how the AI is working at every level.
Wow, that sounds like a lot of data to keep track of.
It is, but fortunately, we have powerful tools for log analysis and anomaly detection.
So we can automate a lot of the monitoring process.
Exactly. It's like having a team of engineers constantly monitoring the enterprise's systems.
Making sure everything is functioning as it should.
And if something seems off, they can investigate and take corrective action.
Okay, this is all starting to make sense now. We've got retrievers finding information, generators creating responses, guardrails keeping everything safe,
routers directing traffic, caching, making things more efficient.
And now right actions, enabling AI to actually take action in the real world.
It's an exciting time to be working in AI.
It really is. But as with any powerful technology, we need to be mindful of the risks.
Absolutely. Responsible AI development is crucial.
We need to ensure that AI is used ethically and for the benefit of humanity.
And that's a responsibility we all share.
Well, I have to say, this deep dive into our RAG systems has been an incredible journey.
It's been a pleasure exploring this fascinating topic with you.
And I hope our listeners have enjoyed it as well.
If you're interested in learning more about our RAG systems,
be sure to check out the resources we've linked in the show notes.
And until next time, live long and prosper.
And may your AI always be trustworthy.